Okay, hi everyone. We are going to learn about the gradient of horizontal lines. Okay, we've learned what gradients are about. Gradient means the measuring the steepness of a line. Okay, so in this particular example, we have two horizontal lines. Okay, look over here. There's one over here. And the equation of this horizontal line is y equals to 3. And it cuts the y-axis at 3. Okay, that's the equation of the horizontal line. The other horizontal line is over here. It cuts the y-axis at -2. So the equation of this line is y equals to -2. Now, for horizontal lines like this, the gradients are going to be very simple, 0. Okay, so the gradient of any horizontal line is actually just 0. Okay, easy guys. Okay, next one. What about gradient of vertical lines? Okay, now vertical lines, you can see there are two over here. Okay, the first one over here is passing through the x-axis at -2, and the equation of the line is x equals to -2. The other vertical line is passing through x-axis at 3, and the equation of the line is x equals to 3. Now you can see that these two vertical lines, okay, the gradient goes upwards, straight upwards. So what are the gradients of such vertical lines? The gradient is going to be infinity. Okay, infinity means what? It's so big, it's uncountable, it's totally undefined. Okay, so we write it as undefined or infinity. Oops, sorry, I don't know what happened there. Okay, so for both lines, it's infinity or undefined. Okay, okay, so the gradient of any vertical line is, now how do we spell infinity? Okay, infinity stone, right? And undefined over here. Oops, wrong. Missing E there. Okay, now I missed out one particular slide here. Okay, parallel lines. Parallel lines like L1 and L2. See, what do you think? What can you tell about their gradients? Their gradients are the same, right? So if let's say I have to climb the two slopes, L1 and L2, okay, they will be the same steepness, so you will have the same kind of difficulty, right? If it's going to be easy for both, then it's going to be the same. On the grid, the graphs L1 and L2 are parallel, so these are parallel lines. So what is the gradient of L1? Now let's look at L1. I'm gonna try to find the gradient. Okay, so remember that okay, I think the line's a bit off, but this is supposed to be over here. Okay, and it just ran off for some reason. Okay, so gradient is supposed to be rise over run, right? Okay, so rise over run. This is the rise and this is the run. What is the value of the rise? Let's count boxes. 1, 2, 3. Okay, and what about the run? Let's count the boxes again. 1, 2, and 3. So run is also 3. So the gradient of L1, oh wait, we must know whether it's a positive or negative gradient. So as I move from left to the right, I'm actually going upwards, guys. So it will be a positive gradient. Okay, positive rise. Ooh, over run. Sorry guys, very messy. I'm not used to writing on a computer screen yet. Soon I will be. Then I'll have fabulous handwriting. Okay, so 3 over 3, which is positive 1. Now what about L2? L2, I'm going to use these 2 points over here. They are actually supposed to be directly in the middle of the, okay, for some reason it's not now. Okay, so we have rise over here, which is how many boxes? 1, 2. So 2 boxes. And the run, which is how many? 1, 2. So also 2. Okay, 2 units, right? So again, because it's also going up, so it's going to be positive rise over run. So it's 2 over 2. is equals to positive 1. So when two lines are parallel, like this L1 and L2, they have the same gradient. Okay? Alright, so we stop here for now. I'll continue part 2 in a while.